So I'm here today with Jeremy Marvel at NIST, and he's working on how to bring safety into AI and automation. So Jeremy, tell us a little bit about the kinds of things you've been working on lately.
So lately we've been working primarily on the performance of collaborative robot systems. So this includes things like human-robot and robot-robot collaboration, coordination, safety, communication efficacy, the ability to understand high-level information and then be able to communicate that effectively amongst robots and people, and then use all of this information in order to build up a good level of situational awareness for the collaborative team.
Now, how have robots and humans communicated in the past, and how do you see that evolving?
So in the past, everything came through very basic communications, either through teach pendants or some kind of simplified interface like light towers, or simple graphic user interfaces through a programmable logic computer, where it was basically process information being shared with the person, and it was very high level information like, is everything okay? How many cycles have gone through? Is there something stuck in the feed system? That kind of stuff.
What is a teach pendant?
A teach pendant is literally this device that is connected to the robot's controller, and this is the primary interface for that particular robot. It allows you to do programming of robot motions. It allows you to get diagnostic feedback. It also allows you to program digital inputs and outputs and analog inputs and outputs for that robot, and basically it's everything that is necessary in order to get a robot to do what you want it to do.
So did these sort of things, like this way of interacting with the robot, it sort of took you out of the flow of getting the work done?
In some cases, yes. Ultimately, it comes down to there being several different roles of interacting with the robots. So you've got the person doing maintenance or programming or just the day-to-day operations. So for the maintenance and programming aspects, the teach pendant is actually a very useful tool and is ultimately something that they rely on quite a lot in order to get their jobs done. For the day-to-day operations, it's not so much important. You may be able to say, well, I need to start up this program, select it, and then press play. And that's about it. And then the teach pendant then goes onto a hook somewhere and is largely ignored until the day shift is over, and then it's the next person's job to come in and start working with the robot.
And what's starting to happen now in terms of enabling more collaborativity, so to speak?
The teach pendant itself is evolving quite a bit. So gone are the days where the teach pendant was maybe a single line of text filled with lots and lots and lots of buttons. Each of these buttons has maybe numerous different functions. And the teach pendants of today are actually greatly simplified, so it's largely just a touch screen that can change its appearance based on the application, based on the user's access levels. And so it now becomes part of the process itself. So you're actually injecting the person into the manufacturing process. In some cases, we also see robots that no longer require inputs from the teach pendant, but can take feedback directly from the person himself. So for instance, technologies like series elastic actuators, which we see in a number of different robot platforms, allow you to literally move the robot around and program it that way without actually having to put it into a programming mode. In some cases, we also see some robots that have integrated artificial intelligence and machine vision such that programming a robot to do simple pick and place is literally see this thing here, put it there, play, and it just goes from there.
And how, like in the past, robots were sort of cordoned off to protect people, and like one of the goals sounds like of at least better collaborativity is allowing humans and robots to work closer and be more efficient together.
Yes.
How do you see that evolving in terms of the technologies and practices that?
So up until now, that has been strictly forbidden. Basically, all of the standards required that there be some kind of physical barrier between a person and the robot. Sometimes that physical barrier can be just a simple like bar going across, or sometimes it could be a 10-foot tall fence. But there always had to be something in between you and the active robot in order to protect the operator at all times. With the acceptance of this new technical specification from ISO, so this is ISO Technical Specification 15066, which was published in 2016, it introduced 4 new collaborative operations or safety functions that allowed people and robots to actually work around one another, not necessarily with one another, but around one another without requiring the fences. These safety functions include things like safety rated monitored stop. So in traditional industrial robots, whenever there's any kind of safeguard fault, i.e. somebody opening up a gate or getting too close to the robot shuts down and the program stops and has to have a manual reset. With safety rated monitored stop, it's actually more of a software pause function. The robot is still active, the drives are still enabled, and as soon as whatever fault had caused that robot to pause in the first place is cleared, the robot is allowed to then automatically resume operation. So that's completely new. Then we also have hand guiding, where in the past during teach mode, so literally where the robot is in a reduced velocity state, you can drag the robot around. It has to be enabled by a 3-position enabling device and basically teach individual positions, and then those can be then played back. With hand guiding under the Technical Specification 15066, the robot is active, running a program when you're doing this. So it's within a very confined space, so this is the collaborative space, and if you ever move the robot outside of that space, it goes into a safety rated monitored stop. But within that area, you can actually use the robot as an assisted lift device, or even help kind of correct minor position and orientation errors in real time while the robot is still running a program. Then we have speed and separation monitoring, which is effectively an environmental monitoring system where it's keeping track of people as they move throughout the environment and keeping track of the robot as it's moving and doing its thing. And that if there's ever a situation where there's a likely collision between the two, the robot shuts down. So basically what it's doing is it's monitoring the speed of the person, speed of the robot, and using known factors like the amount of time it takes for the robot to stop, the sensor uncertainty of the person detection, the likelihood of reach, that's maintaining this virtual distance, that if that distance is ever violated, then it knows that it can't safely stop before the person makes contact. And under the assumption that there will be contact, we get power and force limiting, which basically is saying with an active robot working next to a person, the transfer of forces and pressures onto the body of the person from the robot shall not induce any kind of injury. And so for power and force limiting, there's actually a full body model with different pressure and force limits based on the different types of contact that you may have. So you've got the quasi-static, which is literally being stuck between a robot and a hard place. And then you've got the transient contact, which is more of a free body kind of collision, where you're able to recoil backward, but not necessarily fall onto something else or be crushed.
So those are the 4 new elements of this ISO standard
the 4
that
new
allows
robots.
Functions. And so when you say they weren't allowed to work with people, is there like a law or regulation that shifted, or that there's an industry norm that people wouldn't put them together, and now that there's like this defined spectrum, people feel more comfortable about putting them together for risk management reasons?
A little bit of column A, a little bit of column B. So standards are voluntary until they're not. So there's two ways that a standard can actually become regulatory. One is when a regulatory agency, sort of like OSHA, adopts that standard for their requirements, or when it's part of a legal contract. So we assume that you're following these standards. Within the United States, the regulatory agency that takes the robot safety standards and then makes them mandatory that you follow them is OSHA. And if OSHA says that you have to adhere to these, you have to adhere to these. And up until now, OSHA has been working on considerably older versions of the standards. And so they're actively trying to update their requirements to meet the current state of the art, and then inform all of their field agents with the appropriate information, basically saying it's okay to have collaborative robots, because up until now they weren't aware that they even existed, because these things take time to propagate.
Yeah, yeah.
And there is still a level of acceptance from the end users and the integrator side. So whoever is integrating these collaborative robots into any kind of manufacturing process assumes some level of liability. And if they're not doing things correctly, even a robot that is inherently safe could be doing something that is inherently unsafe. And so as part of a risk assessment, you actually have to determine whether or not certain levels of collaboration should be allowed, or whether or not you should just go ahead and put a fence around the robot, even though it's being marketed as a power and force limited robot or speed and separation monitored robot.
Now, what is the kind of collaboration that you see in practice today, and how might that evolve either with the adoption of these new ISO standards, or perhaps even more stringent or more elaborate sort of standards going forward?
In terms of direct collaboration, the biggest or the most common application we've seen has been human-robot handoff. Person handing a robot a workpiece, the robot then taking it and doing something with it and then handing it back. That's the most direct mechanism. In some cases, we'll see the robot and the human working simultaneously on a workpiece, but not necessarily towards a common task goal. But more often than not, the robots are actually just off doing their own things. They just happen to have people working around them, such that if somebody were to accidentally bump into the robot or get too close to the robot, they won't be injured, but the robot is still being more or less treated as though it's a standalone kind of monolithic system.
So is there anyone working on bringing camaraderie to these robots? I mean, like humans, when they're working,
Yes.
like they're having fun. I mean, is that something that you see coming or being baked in any meaningful way?
Yes. So there have been studies in the past where, in particular, humanoid-like robots, or robots that people work with on a regular basis, form some kind of emotional bond with, much to the chagrin of some people, because there are some in the industry who say that robots should actually look more like multi-tentacled alien monsters, such that people aren't tempted to go anywhere near them because they're still very dangerous. But people do form bonds with certain robots, especially if it's something that has directly impacted their job in a positive way. And there's a number of different technologies that need to improve before we can actually get to that point where we see true camaraderie. For instance, can the robot actually communicate using typical either hand gestures, facial expressions, natural language processing, something that actually allows the person to interface on a more natural level. There also needs to be better standards or test methods to verify that the robot is at least aware that a person is there, and that is aware of what that person is doing. Take for instance, two people taking a piano or a couch up a flight of stairs. You may not necessarily be able to see your buddy up at the top of the stairs, but every time they shift or try to get a better grasp, you can feel it. And so the robots need better intelligence as to how to interpret that kind of information, such that they're not necessarily saying, oh, you're trying to turn this way, so let me just swing you off the edge. And so there needs to be verifiable and validatable methods of actually working together. And it comes down to a level of trust, that you have to be able to trust the robot to understand what it is you're doing, and that you can then trust that you understand what the robot is doing. So there needs to be a level of clarity and of correct intent prediction.
How do you see this whole field evolving over the next 5-10 years?
I'm excited about it. Artificial intelligence, as you mentioned, is a very hot topic, and we see it eking into all different levels. So machine vision is exploding in terms of performance and cost reduction. Natural language processing is getting better and better thanks to things like Siri and Amazon Echoes and Google Home. Just the sheer amount of information that is being consumed, allowing automated systems to be able to interact on a more natural way. It's still not there perfectly, so we're not necessarily at Rosie the Robot from the Jetsons, where they're just going to start cracking jokes and just having fun around the water cooler. But we envision a lot of the capabilities growing. So no longer will you see these monolithic robots on pedestals just doing their things. We see a lot of mobility. So robots on mobile platforms, be they wheeled or legged. Robots being able to interact with other robots in order to accomplish shared tasks. And then in turn maybe even saying, hey, you human over there, we need some help with this. Can you do this for us? Being able to recognize their own limitations is a huge aspect of the human-robot teaming, mostly because we see these collaborative robot technologies not necessarily being a mechanism to replace people, but a way of actually improving the human labor, making them more efficient, safer, and ultimately better at doing their jobs, and ultimately more important within the job community.
Thank you.
Absolutely.
How can we track you down on the web or Twitter?
So I do have a Twitter account. I very rarely check it. It's at Jeremy Marvel. I got on very early before I actually had to come up with clever names. Otherwise, I can be found at NIST via my email account, jeremy.marvel@nist.gov. And if you're interested to see what kind of research that we're putting out, if you go to nist.gov on the main website, on the far right there's a drop-down menu for publications, and you can search for my last name, and we'll have a list of the recent publications and research that we've been putting out.
Thank you.
Absolutely.